So, our today's topic is scaling or scalability. So, in software development, there are some concept we call as a NFR, non-functional requirement. And when we are developing any software or any application, so at the time we need to implement some functionality, and the scalability is one of them. So, let's start our today's topic: scalability or scaling. So, what is scaling? Uh, you can see the simple definition. Scaling is to increase or decrease the capacity of system or server to handle the varying workload. For example, we have some microservices or some services, right, which are deployed on server, and the server we have some configuration, for example, some 8 GB RAM or something, right? There are some hardware configuration, right? So if we observe the workload is increased on that server, right? So to increase the capacity to achieve the same performance, what we can do, we can increase the capacity of the server. So there are two type of scaling. There is two way to increase the capacity of the server so that we can achieve the same performance and there's a no error, right? So there are two types of scaling or scalability. One is a horizontal and another one is a vertical. So in this diagram, you can see this is the vertical scaling and this is the horizontal scaling. In vertical scaling, we are increasing the RAM and CPU, etc., right? Whatever hardware configuration we are increasing, we are applying on the same machine. For example, I have a only one computer, right? Or one computer where my server is running. So I'll increase the RAM size. So this is kinds of the vertical scaling. And the horizontal scaling means I will add parallel multiple computer or multiple CPU with the same configuration. So this is the horizontal scaling. We'll see vertical and horizontal scaling in detail. Let's start with the horizontal scaling. So what is the horizontal scaling? As we already seen in this diagram, right? Horizontal scaling means we are adding a parallel CPU. Whatever configuration we have, right, in a one CPU, we will add the same CPU. Okay, before discussing this horizontal scaling, let's see the one use case. This is the one use case. Imagine we have a e-commerce platform, right? And during the flash sale, for example, in Amazon or Flipkart, there is a sale time. So at during the sale time, the traffic or number of user suddenly increase. So to handle the application workload or serve the all request, we need to increase the capacity of our application. So in this case, we can go with the horizontal scaling. What we can do, we can add the parallel CPU, and each CPU handle the request, user request, and serve and return the response. So this is the vertical scaling. So there are some key points when implementing the vertical scaling. One is the new instance can be added or removed dynamically based on the traffic. So as we seen, we can increase the new instance or we can decrease the new instance. Let's see the one more use case or example. For example, in India, there is a IRCTC website, and during the Tatkal, there is a 10 a.m. is a Tatkal timing where everyone logins and search for the Tatkal ticket, right? So at that time, the number of user are very high. So what we can do, we can add the number of user at the Tatkal time, and during the normal time we can remove the number of user, right? We can, for example, we will keep for example 3 CPU on normal time, and during the tatkal time we'll add more CPU, 10 or 15 something, right? This is just example, right, for understanding. So In this horizontal, new instance can be added or removed dynamically based on the traffic. If the traffic increase, we'll add more. If traffic decrease, we will remove extra whatever we have added, extra instance. So this is the one key point. And second is to ensure high availability and fault tolerance. If one instance fail, other can continue serving requests, right? So if we are adding a more CPU parallel, so it will provide a redundancy also. For example, we have added a 10 CPU. The total count, CPU count or instance count is a or computer count is a 10. One is failed, so other nine will work. So this is the one advantage of the horizontal scaling. Third one is a distributed load. So if we are adding a more instance, so what we need to do, we need to add the load balancer, right? So load balancer for load balancing, I'll create a different video. Load balancer is a just a balancing the traffic. For example, if there are 10 user who hitting the request at HTTP request, right? So one request goes to server 1, another go to server 2, another go to server 3, like this. There are different algorithm and load balancer. We'll discuss this. So the distributed load, the load balancer will distribute the traffic amongst the instance. This is the key point, right? And what are the benefit if we use the horizontal scaling? So what are the benefit to using the horizontal scaling? See, we have a vertical scaling also, and we'll compare both horizontal and vertical scaling and which one to use, right? This is the very important for designing any application. So first we'll see the horizontal scaling, then vertical scaling, and we will compare. So as of now, we have seen the definition and the key point, whatever key point in this horizontal scaling and the benefit. Now, the benefit. So it will improve the fault tolerance and reliability, sorry. And this is the isolation of the failure of individual instance, right? So for example, one instance we already discussed, if one instance is failed, right? So other will work. So this is the isolation. For example, I am adding 10 more, and if the traffic goes high, I'll add 10 more or 20 more. If one or two goes down, so it will work, right? So this is the isolation of failure for individual instance. And to implement this horizontal scaling, there are some challenges also. This is the one most important challenge. We require stateless service. See, there are two types of service, stateless and stateful, right? I'll discuss this on next video, what is the stateless and what is the stateful. So what it's required the stateless service, and for implementing this horizontal scaling, we need a careful management. When we and the next is when we implement this horizontal scaling, so we need to implement the load balancing also. So our system is depends on load balancer also. For example, in case our load balancer goes down, so the server will not work, right? Our application will not work. So there's a one more dependency. And obviously if we are adding more servers, so it will increase the complexity. Monitoring also increase, and managing multiple instance also a very difficult task. So for this use case, we already discussed this use case, right? During this sale, Amazon and Flipkart, if user is increase, right? So we can handle this. So this was related to the horizontal scaling. Now the next is vertical scaling. So what is vertical scaling? We already seen on diagram, right? There's the first diagram. This is the vertical scaling where what we are doing, we have a one server. In the same server, we are increasing the RAM and CPU size. So this is vertical scaling. So let's see the definition. So it involve increasing the resource, CPU, memory, and storage for existing server or instance. So in this case, we are not adding any instance. Whatever instance we have, existing instance, we are increasing or decreasing the resource like CPU, memory, or storage. So instead of adding more instance, the capacity of a single instance is enhanced to handle the workload. You can see in diagram, this is the arrow where we have only one server and we are adding the same thing, right? So benefits. What are the benefits to use the vertical scaling? There are so many benefits. The easier implement to stateful application. See, horizontal we are using for stateless and this we use for stateful. This is very important concept. For this, the another benefit is there are no change in service distribution or load balancing because we are scaling the same server, whatever existing, right? And if we are not changing any configuration, we are not adding more instance, so the monitoring also the very simple. But there are some challenges. For example, you are increasing the RAM for the particular machine or CPU or memory, but there are some limitation of increasing the hardware. At the point of the threshold or bottleneck, right? It will fail, right? It will fail to serve. So there are some certain capacity. For example, if you have a one computer and there are around 8 GB RAM, right? You increase 8, 16 or 32 GB, right? But after some time, right? It will if you increase 128 GB RAM, but it will not work. So this we call as a capacity of hardware and the potential single point of failure. This is the very challenging point. For example, whatever you are adding on a single server. And let's say if your server goes down or fails, so you are not able to serve any request because you have a single point of failure. You have only one server, but in horizontal case of horizontal scaling, there are number of server on the parallel and all server are independent, right? But in this case, we have only single point of failure. Uh, In some case, it's most expensive for high performance hardware requirement. There are some use case, let's say, where we can use this vertical scaling. So in some small startup runs a single instance analytics service instead of deploying multiple server, what they can do, they can upgrade their existing server, existing computer server resource, and they can increase the computation demand, right? So there are two type of scaling: vertical scaling, horizontal scaling, and generally in most of the case we use horizontal scaling. You have seen we have created in your project or any application. You can see many created number of instance parallel, and they are using the horizontal scaling, not a vertical scaling. Now the next point is when to use horizontal work versus vertical scaling. So for example, there is a one criteria. First column is criteria. There's a traffic growth. For example, we have a traffic growth. If the traffic growth is rapid and unpredictable, for example, the Okay, let's say one example, the cricket match, right? So cricket match is let's say today morning 9 a.m. India and Pakistan, the cricket match will start. So we can predict the number of user for checking the score is increase, right? Will increase. So we can predict. In this case, we can go with the vertical scaling, but sometime, right? Suddenly a rapid, unpredictable user increase, so we'll go with the horizontal scaling. This is the most important point to implement either horizontal or vertical scaling. There's a second point, application architecture. If your application architecture is stateless or distributed, you can go with the horizontal scaling. If the architecture is stateful, you'll go with vertical scaling. And next is a budget. Obviously, budget is a most important constant. Scalable cost with the infrastructure, higher upfront hardware cost, vertical scaling. Fault tolerance, if the fault tolerance is the important criteria, so in this case, the horizontal scaling is high because it's provide a redundant instance, separate instance. So a single point of failure will decrease, but in this case, single point of failure. So there is a low, fault tolerance is low. Last one is a implementation complexity. So in this case, the implementation complexity is very high because there are so many server parallel running. So tracing also very problematic. So there's a higher, and in this case lower. Some best practices for scaling microservices. Design for scalability. So first we need to ensure service are stateless where possible and externalize state to database or caching layer. For example, we are performing or we are implementing the scalability. Let's say horizontal scalability. So what we need to do, we need to ensure the service is stateless. Yes, this is our server service is stateless and externalize state to database. So we are externalizing the database, right? In whatever current architecture we are using. Caching layer also we are externalizing. We are not keeping on this same server. Monitor performance. So bottleneck and scaling need, if we are implementing the microservices, so yes, we need to monitor the bottleneck and scaling is needed. Automation, leverage automation. So to implement the scalability or scaling, we need to implement the also auto scaling. There are so many features available on the cloud side. We can automate this process. We can dynamically based on criteria. For example, if user count is more, so it will all automatic increase the instance. It if user count is low, it will automatic delete the instance. And next is optimize resource allocation. So to optimize resource allocation, what we can do, we can use the containerized orchestration platform like Kubernetes, right, to efficient scaling and resource management. And the last one is the test scalability. Whatever we have developed regularly, we need to test whether what whatever we implemented that will work or not. So top this was related to scalability. We have discussed horizontal scalability, vertical scalability, and which one we need to implement based on the criteria. And these are the criteria: traffic, architecture, budget, fault tolerance, and complexity. So this is the very important point or important topic that we need to keep in mind while interview or developing any architecture. Thank you.